Hello, ladies and gentlemen. Mr. Dorfler here. I'm doing my first lab for honors chemistry this semester. The lab we're going to be doing, if you can see it, is discovering density. Hopefully, you can see it a little better. Maybe if I angle this down. Okay. Sorry about that. But anyway, I just hold up the packet that you should have already received through Classroom. If you are a remote learner or you were absent on the day of the lab, you can get your copy straight from the posting I did a few days ago from Classroom. Anyway, before you do any lab, you should always look at the background, look at the concepts and everything like that. Okay, this lab is kind of multifaceted. I use it because I like when we can do a lab that kind of gets the rust off the gears, as I mentioned in class, gets them prepared to see kind of the format of the labs, what the wording is of the labs that we're going to be doing this year, because they all look very similar to this. And it also brings out some really good concepts that we learned from this first chapter. Density, and we're going to be looking at density, calculating density, but not just density of any objects. We're going to be calculating density of irregularly shaped objects using water displacement. And then we're also going to look at precision and accuracy. The equipment that we're going to be using today are fairly basic, but they're very common and necessary in laboratories. And so you're going to see just how precise and accurate your readings will be using the specific equipment. And then you're going to base your abilities and calculate your level of uncertainty or percentage of uncertainty in your post-lab questions. I'm going to talk all about that here before we get started, okay? The lab itself doesn't take very long to get going, especially that I've got things already set up, ready to go. I'm going to do my best to help you observe as I go through this here. I'm going to try an approach this time where I am going to kind of get you started, okay? And I will work through it, but I'm going to have you make the readings after our initial reading, okay? And you're going to follow along with me as we document this. We're going to fill out the data table, and after I fill out the data table, I'll describe to you what you need to do from that point forward, okay? So again, anytime we do this, I generally assign the pre-lab questions. Here we can see the pre-lab questions, 1, 2, and 3, typically range between 2 and 4 questions. But I always recommend that you read the background thoroughly. It helps you out a lot. You can go through in the lab, the procedures and the post-lab questions while answering the pre-lab questions can help you out a lot too. So those of you who are absent or are remote learners, I do need the pre-lab questions on a separate piece of paper. If you are absent, make sure they get to me the next time you're in class. If you were a student who was a remote learner, make sure you either take a picture of your pre-lab questions that are answered or scan them and upload them to me. You can either upload them to Classroom or upload them to email them to me, okay? But before you come into any lab, you want to look at the precautions as well as any procedural steps, okay? There's always going to be procedure, so you want to make sure that you go through all the steps before you come into the class period so you have an idea of what to do. One of the most important ones, if you are following along with me, which I hope you should, if you look at the very last step, step 9, it says you are to repeat steps 6 through 8 and do not remove any of the BBs or water from the graduated cylinder after each trial. We are simply going to be building up after each trial into the graduated cylinder. So I have already gone through and labeled and measured 5 different weighing dishes with our metal shot, or BBs. I guess we are more apt to call them BBs since we do have a couple of school buildings that have them as a mascot. But anyway, this is what I'm going to do. I've got these labeled 1, 2, 3, 4, 5, which also happens to coincide. I'm trying to get the best lighting here. Coincide with the data table samples 1, 2, 3, 4, 5. All right. So as you're going to see here, I have these You know what? I'm going to try to turn off some of these lights here. Hopefully that works out a little better, and I really hope we're able to see this. Okay. Oh, that's much better there. All right, so my first weighing dish of the BBs has a mass, I've already measured, as 8.23 grams. So I'm going to put 8.23. Now, I'm not going to put the label here because we've already got the label up here, and that will be kind of an umbrella for us as we fill this out. Our second one is 9.93. Might be a little hard to see. Third one, 13.6. Oops, sorry, 13.06, excuse me. Number 4 was 16.13. And our fifth one is 18.10. Okay, so that's what you should have in your first column here. Next we need to do is we need to identify and use the graduated cylinder to help us determine the initial volume before we put any in here, okay? So I've kind of dyed the color blue so it'd be a little easier to see on camera. All right, let's see if I can't block off some of the light there. All right, now these increments on this particular graduated cylinder go in half milliliters. So we have large increments of 0, 5, 10, smaller increments of 1, 2, 3, 4, 5, and then in between those we have half liters, okay? So if you're able to see here, okay, we read from the meniscus, I see that the initial volume is right there from the meniscus. So halfway between 10 and 11. So I would say that my initial starting volume is going to be 10.5. Okay, 10.5. And again, I don't have to put centimeters cubed or milliliters because of the same unit, but we've got this up here. It's already labeled for us. All right, now what I'm going to do is return back to the camera, and I'm going to take my first mass, which is the 8.23 that we put in line number 1, and I'm going to very carefully add that sample to here, making sure that I tilt it, because if I were just to keep it straight and pour these, there's a chance that I could have the graduated cylinder break when the metal hits it, because there's really not that much water. I'm starting off with 10.5 milliliters or cubic centimeters, whatever way you want to call it. So tilt it to the side, squeeze the weighing dish gently, making sure they all get in there, and then I place the graduated cylinder back on a flat surface, and I get eye level with it. I'm going to try to get all the air bubbles out of there, okay? And if you can see that, if I pick this up here, okay? I am reading, I know, I'm sorry, there's really no best way. That kind of looks all right. For our final volume, after we get this one, I'm getting about 11.5. I'm going to try to steady my hand here. 11.5. Okay? Do you agree with that? I think based off of how this is going in terms of visibility, I think I'll go ahead and fill this out for you. All right. Sorry. So we go to 11.5. Okay. We'll worry about this here in just a few moments. Now, the final volume in row 1 now becomes the initial volume in row 2. Because again, I said we're going to build off of the previous one. So again, now I take sample number 2, tilt my graduated cylinder, place it back on a flat surface, and again, try to determine. I'm going to try to get some of the air bubbles out. Okay. I'm not sure if you can see, but I'm getting approximately, let's see, we've got 10, 11, 12, just about 13 cubic centimeters. So we're going to put 13.0 there. Now, again, we're going to transfer that number, 13.0 there. Follow the same procedures. Okay, we're on to number 3 now. Tilt, pour, place down, get all the air bubbles out, measure. All right, I'm not certain if you can tell there. Okay, that kind of works better, doesn't it? I'm getting about some interference from some air bubbles, I can tell you that. I've got about 14 and a half. See, it's right there. 14 and a half. Okay, so again, I'll put that there in my file. Transferring that down in here to my initial. I've got 2 more masses I need to do. Making sure I pick up the correct labeled one. Again, tilting. Put that back. Put that back down there on a flat surface. Come back here. See if you can see that. See if you agree with me. I'm getting about, see, 15, there's 16, about 16 and a half at the bottom of the meniscus. So, when I say 16 and a half, and then lastly, that gets transferred down here. And then we do the steps one more time with our last sample. You notice how all of my samples are different masses. That's because if you were to have all of your samples have the same identical mass, you go to graph this, you're going to have a single data point here because they're all going to be equal, okay? So you always want to vary your masses. Our last measurement, again, if you can see, and I'm getting just about 19. Okay, right about there. Okay, so 19.0. Okay, so that's it. That's our data collection. Now, what I need you to do for you absent and remote learners is this. I need you to complete this column. This is your sample volume. So in order to do that, you take final volume minus initial volume. So you take the difference, final minus initial. So 11.5 minus 10.5, you get 1.0, okay? Just like that. You need to fill this out, okay? Then you're going to graph your data. Okay, it says plot the mass and volume. You're going to use, let's see, where is it? You're going to use the horizontal, so this way, for the volume, and the vertical for your mass. Okay, so this is the mass you're going to use. The volume, it doesn't clearly state that you're going to use is this column. Okay, so once you complete that, you can then come to your graph, set up your scale, making sure that your scale fits all of these masses, okay, neatly, and your scale for your volume fits all the volumes that you're going to calculate here, okay? So after you've done this column, you're going to graph, and then for you absent individuals, if you are in the B group, these are going to be due next Thursday. the 17th. If you are an A group absentee, then you will have to have this turned in by Tuesday, the 15th. There we go. Do my math here. Okay. If you are a remote learner, you are to have this done by Thursday, September 17th. Okay. Now, we are not doing number 9. I've made the decision to make that optional, it's not optional. We are not doing it. Okay. But questions 1 through 8, you have to answer on a separate piece of paper when you turn them in. You will also turn in your data table and graph. You're just going to simply tear it off, staple this to your notebook or loose leaf paper with your post-lab questions and their answers. Make sure your name's on it, and you'll turn it in when I see you next. But again, if you are a remote learner, you need to get these turned in by the 17th. And don't forget, you have to have your pre-labs done. Okay? Need to have your pre-labs done and turned in. If you're remote, you need to have them uploaded to either email or a classroom here by the end of the week. So end of tomorrow, Friday. And then if you are an absent person, you need to get them done and turned in next time I see you. If you have any questions, please email me. Again, this is my first time doing a lab. They will get better. It's always a trick trying to figure out the lighting and everything like that, because the stark contrast between paper color and the color of my desk and the color of the whiteboard behind me. So get that done. Again, get a hold of me if you have any questions. Until then, I'll see you later.